So now we will discuss some important points of SN2 reaction. Clear? First one is here. This is a single step reaction. Only transition state formation takes place, but it is not intermediate. Clear? So it is a one step reaction. Clear? It is a single step reaction. Single step reaction. Clear? And it is a second order chemical kinetics. It follows the second order kinetics. Means that rate I have already mentioned is equal to K into alkyl halides concentration into OH minus concentration. Clear? Order how we will calculate means, and in the rate law, this we will call as a rate law, we will study in the chemical kinetics, and the powers of the sum of the powers of the concentration terms in the rate law we will consider it as a order. Means here power how much? 1, and here power how much? 1. 1 plus 1, 2. So that's why it follows the second order kinetics. Clear? And third one is no intermediate formation takes place. No intermediate in this reaction. Only which one is formed here? Only transition state. Only transition state is formed here. Clear? If there is no intermediate, then there is no chance of rearrangement. No rearrangement. Clear? If suppose intermediate is there, suppose carbocation is an intermediate or free radical is an intermediate, then there is a chance of rearrangement in the reaction. But here there is no intermediate, only transition state, so that's why there is no rearrangement in this reaction. We will not observe any rearrangement. Clear? And the next one, fifth one. Clear? You know that in the transition state, which charges are present here? Partial negative charges. Means here which one is there? Alkyl halide is there. Clear? And you know that. And this second one, if nucleophile is a strong nucleophile, then the SN2 reaction takes place very fast. Why? Because rate of the reaction is directly proportional to which one here? OH minus ion means nucleophilic concentration, means strong nucleophile favors this reaction. That I will discuss. And first of all, here in the transition state, negative charge is present. Means if alkyl halides with the electron withdrawing group increases the rate of SN2 reaction. Why? Because you already know that. If electron withdrawing group are present here, what that electron withdrawing group it will do? It will withdraw the electrons. If it withdraw the electrons, negative charge concentration decreases in the transition state. If charge density decreases, stability increases. Charge and stability both are inversely. You know that if charge is low, stability will be high. So that's why if electron withdrawing groups are present, then automatically and here charge on this transition state decreases, charge density decreases, then stability increases, then speed of the SN2 reaction increases. Means here alkyl halides with electron withdrawing group increases the SN rate of SN2 reaction. It increases the rate of SN2 reaction. Clear? So I will say simple example. In this one, and later I will discuss what is that example. Clear? And now, if you see here, which product we got here? Walden inversion. Means SN2 reaction is a stereospecific. It is what it is? Stereospecific. Means specifically we will get one product. What is that product here? Inversion product. We are getting only one product, so it is a stereospecific. Clear? Now we have to discuss here. Next point is what is the, I already mentioned, the rate of reaction depends upon the alkyl halide concentration and OH minus ion concentration. So which alkyl halides increases the SN2 reaction? Means we know primary alkyl halides, secondary alkyl halides and tertiary alkyl halides. You know that in the mechanism, if you observe, the nucleophile attack takes place from the back side. Clear? Means you know in the methyl chloride, hydrogens are there. Hydrogens are, you know, very small groups. Hydrogens are small groups, so that's why. And OH minus can easily attack on the carbon. So SN2 reaction is very, very fast. If I take, suppose, if I take here methyl, I will take here hydrogen and hydrogen and hydrogen and here Cl. Second one, I will take the ethyl chloride, CH3 and H and H, and here Cl. And the next one is CH3 and CH3 and H and Cl. Last one is tertiary alkyl halide. And this is, first one is simple methyl chloride. It is a primary alkyl halide. It is a secondary alkyl halide. It is a tertiary alkyl halide. Now, which one attack takes place here? OH minus ion attack takes place on the carbon of alkyl halide. From which side? Back side. So here, you know, these are very small groups. It can easily attack. Clear? But if you consider here, CH3, CH3 and CH3. If I write here, see here, CH3 and here tertiary alkyl halide I am discussing here and Cl. So which one has to attack here? OH minus ion has to attack. And you know these are very bulky groups. Clear? And is there any space for the OH to attack on the carbon? No. So they hinder the attack of OH minus ion on the carbon. They are not giving the space for the OH minus ion to attack on the carbon. So that's why OH minus ion, it cannot easily attack on the carbon atom. So that's why, and here nucleophilic rate of the nucleophilic substitution reaction will decreases. Means, you know, alkyl halide should be very, very, very less hindered than the rate of reaction increases. The rate of reaction is very, very, very fast. So if you take here also which one is there? Two bulkier groups are there. As compared here, somewhat OH minus can attack here somewhat easily. But here two hydrogens are there. Attack can take place somewhat easily. So methyl chloride, in the methyl chloride, OH minus attack takes place very, very, very fast compared to the primary, secondary and tertiary. In the tertiary, almost SN2 reaction we will not observe. SN2 reaction will not take place in the tertiary alkyl halides, you know, because bulky groups will not allow the attack of OH minus ion on the carbon atom. So what is the order of the substrate here in the SN2 reaction? You know that in the SN2 reaction, and methyl chloride and is involved in the SN2 reaction very fast, and after then, you know, CH3 and CH2Cl, primary alkyl chlorides, and the next one is secondary alkyl chlorides and CH3 and H and Cl, and the third one is tertiary alkyl halide, CH3 and here CH3 and here. This is the rate of speed of alkyl in the SN2 reaction. The speed of SN2 reaction in the alkyl halide is in this way. Clear? And the next one is which one? With the methyl chloride. With the methyl chloride, SN2 reaction is very, very fast. But in the tertiary alkyl halide, SN2 reaction will not observe. Next one. What is the second one? Is what it is here? Nucleophile also, rate of reaction depends upon which one? Nucleophile also. Clear? What is the nucleophile here? Clear? So concentrate strong nucleophiles favors the SN2 reaction. If nucleophile is strong, then SN2 reaction is very, very, very fast. Clear? Suppose if I take example, you know that here O minus and CH3OH. Clear? And species with the negative charge compared to the neutral species are powerful nucleophiles. Clear? So this is powerful nucleophile. Suppose if you take OH minus ion is powerful nucleophile than the water, And another one, SH minus is greater nucleophile, means strong nucleophile. You can say strong nucleophile than the, which one here? OH minus ion. Because nucleophile means what? It has to donate the electrons to carbon to make a bond. Clear? So OH and S, OH here, oxygen and sulfur. Which one is more electronegative? Oxygen. So it cannot give the electrons very easily compared to the SH. So SH is a powerful nucleophile than the OH means commonly negatively charged species act as a powerful nucleophile than the neutral species. Clear? So this is the what it is. So nucleophile means strong nucleophile favors the SN2